So in this video we'll continue looking at the geometry and measurement module of the Further Maths course, and here we are looking at Pythagoras' theorem, which should certainly be a revision. So Pythagoras' theorem provides a relationship between the side lengths of a right-angled triangle. Okay, so if we know any two side lengths in a right-angled triangle, we can use Pythagoras' theorem to find the third one. So in a right-angled triangle, the longest side, which is always the side opposite the right angle, is going to be the hypotenuse. Okay. So in this diagram, the hypotenuse is labelled as C. Now people sometimes get bogged down with A, B and C and where they go. It doesn't matter what you call them. I could call these side lengths P, Q and R. I could rotate them and call this one C and this one A and this one B, and the relationship is still exactly the same. So try not to get bogged down in the formula. So essentially it is the hypotenuse squared equal to the sum of the other two sides squared, or the sum of the squares of the other two sides. So it's really just about clearly identifying which one's the hypotenuse, because that's the length that needs to be on its own in the equation, whether that's on the left-hand side or the right-hand side of the equation. So again, just being clear that this is the same as saying that c squared equals a squared plus b squared, so it doesn't matter which way around you do it, the hypotenuse on its own on one side of the equation, and then squaring the other two sides and adding them together on the other side of the equation. Okay, so let's just work through some examples here then. Find correct to one decimal place the value of the pronumeral in each of the following. So in part A, x, the pronumeral, the unknown quantity, is the hypotenuse. So when we set up our Pythagoras' theorem, it's going to be hypotenuse squared on its own equal to the sum of the other two lengths squared. Okay. Alright, so 7 squared is 49, plus 12 squared, which is 144. 49 plus 144 is 193, and so therefore x is the square root of 193, and so square root of 193, control enter for a decimal to one decimal place, is going to be 13.9, and units here are centimetres. Okay, in part B, here's x over here, it's not the hypotenuse, okay? So we're going to have hypotenuse squared has to go on its own. So I'm going to do these two added together first. So I'm going to say x squared plus 16 squared equals the hypotenuse squared. Okay. Again, you can write 18 squared equals x squared plus 16 squared, or 18 squared equals 16 squared plus x squared. It's all the same thing. I tend to always like to set up the equation with the unknown thing on the left-hand side at the start. Okay, so that's the thing. It makes it a bit easier to think through the solving process. But as I've said previously, you've got a CAS. You can always just put the entire equation into your CAS. Menu 3(1), solve x squared plus 16 squared equals 18 squared for x. And obviously you can ignore the negative solution because x is a side length. So the exact answer is 2 root 17. Control enter to get a decimal, 8.2. Okay. However, you know, you can also do the rearrangement yourself and just get your CAS to help a little bit along the way. So x squared will be 18 squared minus 16 squared if we subtract 16 squared from both sides. So if I work out what 18 squared minus 16 squared is, it's 68. So x squared equals 68. And so x is the square root of 68, which is, let's check that it's the same as what we got when we solved the equation with the CAS. It is indeed 8.2. Metres are the units here. Be careful about the units. Make sure that the units in your answer match the units in the question. So in this part A it was centimetres, part B it's metres. An answer with wrong units, if you'd written that answer was 8.2 centimetres, that's not the correct answer to the question. Okay, so do be careful about that. Alright, part C. So the key thing, if you want to use Pythagoras' theorem, you need right-angled triangles. So if you don't have a right-angled triangle, you've got to look for where you could create one, or where there is one if you just add in an extra line. So if I were to, draw a line horizontally across here so that that's a right angle, then I have a right-angled triangle here. Okay. Now, this horizontal length will be 6.2 because it's going to be the same as that. This vertical height we know that total height is 10.8. We know that height there is 4.6. And so this height here will be 10.8 minus 4.6. Okay? So 6.2. Okay? So this would be 6.2. So just looking at our, so it's actually an isosceles triangle, 6.2 and 6.2. But that doesn't really help us with the Pythagoras. So we're trying to find the hypotenuse. So in terms of setting up my Pythagoras theorem, x squared is going to be the other two sides, each squared and added together. Alright, so let me work out what 6.2 squared plus 6.2 squared is. That is 76.88. And now I can take the square root of that to solve for x. And the square root of 76.88, control enter to get a decimal, is to one decimal place 8.8. I don't have any units on this one, so just 8.8. Okay, part D, we have a triangle, but it's not a right-angled triangle. Okay, so it's not 12 squared equals 4, plus 14 squared equals x squared, or whatever it might be. Also, this 14 meters doesn't correspond to this length here. It corresponds to the height of the triangle. Okay, so straight up and down. And in fact, that's really important, because if we take this isosceles triangle, and it's isosceles because of that, and if we just cut it straight down the middle in half, we form two right-angled triangles. Okay, so that will be a right angle. This will be 6, which is half of 12, and this is 14. Okay, so Pythagoras' theorem, it's the hypotenuse we're trying to find, so x squared on its own equal to 6 squared plus 14 squared. Okay, so 6 squared plus 14 squared is 232. So x squared is 232, therefore x is the square root of 232, which as a decimal, control enter, is 15.2. Have we got units here? Yes, meters. Okay, parts E and F. We've got a couple of triangles going on, and again, it's about making sure that you stay focused on Pythagoras' theorem is only relevant in right-angled triangles. So we're trying to find A, which is here. Okay, so if we're trying to find A, we're going to need to make use of this purple triangle. Okay. However, we only know one side length in the purple triangle, so we actually don't have enough information yet to find A. So we're going to need to first of all think about the green triangle and use the green triangle to find this length here, which will then give us another length in the purple triangle, so we can go about finding A. So focusing on the green triangle, we're trying to find the hypotenuse. I've labelled it as x. Don't label it A. Make sure you use different letters within the same problem. If this was labelled x, don't call this x as well. You can't call two different lengths the same letter. Okay, so in the green triangle, x squared, so hypotenuse squared, equals 15 squared plus 17 squared. Just going to get my CAS to work out what 15 squared plus 17 squared is. So it's 514. And so x is the square root of 514. Square root of 514. Control enter to get a decimal. That is 22.7. Okay, now that's not the final answer. That's just an answer we need in our subsequent calculations. And actually, technically speaking, we didn't really need to even go to this point. And I'll show you why when we have a look at the purple triangle. So now in the purple triangle, we're trying to find A. A is not the hypotenuse. Okay, x, this length we've just found over here, is the hypotenuse. But if we set up our Pythagoras' theorem, so it's going to be a squared plus 10 squared equals x squared. Now this is where I mean we didn't actually need this bit, because actually that's what x squared equals. Okay, x squared is 514. So we've got a squared plus 10 squared, 10 squared is 100, let's do that, equals x squared, which is 514. Okay, you could go and square this value back again, but you'll get 514, that's the point. So actually, we didn't really need to actually work out what x is, we only ever needed to know what x squared was in order to be able to go to A. Alright, so solving this, we're subtracting 100 from both sides, so a squared is going to equal 414, and so therefore A is the square root of 414. Square root of 414, control enter, to one decimal place is 20.3. Okay, you certainly don't want to use a rounded answer in subsequent calculations. So if you had taken this rounded off 22.7 and put that in here, if you'd just done 22.7 squared, you would have ended up with 515.29, when actually it should have been 514. So always using exact values, even if you did use that decimal value, scrolling back up and getting the exact value and using that within your calculations. Okay, part F, we are trying to find D, which is this total length all the way along here. Okay, now the key thing is to not lose track of the fact Pythagoras only works in right-angled triangles. So you can't use this whole purple triangle I've just outlined here. Okay, D squared does not equal 4.6 squared plus 2.3 squared, because this is not a right-angled triangle. Okay, so we need to focus on right-angled triangles. So we have two right-angled triangles here. We've got this small one here. Okay, and we know two side lengths in that, 1.7 and 2.3, so we could find that length at the bottom there. And then we also have this right-angled triangle here, and again we have two side lengths in that, 4.6 and 1.7, so we could find this length here. And then once we found those two separate lengths, we can add them together to get D. Okay, so in the purple triangle, the hypotenuse is 2.3, so we're going to have x squared plus 1.7 squared equals 2.3 squared. So x squared is 2.3 squared minus 1.7 squared. So let's just work out what that is. 2.4. And so x is the square root of 2.4, which is, control enter, approximately 1.5. Okay. And then y in the green triangle, again y is not the hypotenuse, 4.6 is the hypotenuse. So y squared plus 1.7 squared equals 4.6 squared. So y squared equals 4.6 squared take away 1.7 squared. 4.6 squared take away 1.7 squared is 18.27. And so therefore y is the square root of 18.27. Square root of 18.27, control enter. Approximately 4.3, okay, and so therefore D is x plus y, and so that's 1.5 plus 4.3, but again, don't use your rounded answers. I'm going to scroll up here and get my 1.5, which is that, plus my 4.3, which is that, and yes, it does turn out that that rounds to 5.8. So in this instance, if we had added together our rounded off values, we wouldn't have created a slight rounding error, but you can't be sure about that. So make sure that you're always working exactly. There's no reason not to with your CAS. Those exact numbers are just sitting there. All you need to do is scroll up to be able to use them. Scroll up and press enter. Okay, a couple more examples over the page. Find the maximum horizontal distance, correct to the nearest metre, a ship could drift from its original anchored point if the anchor line is 200 metres long and it is 50 metres to the bottom of the sea from the end of the anchor line to the top of the ship's... And is 50 metres to the bottom of the sea from the end of the anchor line on top of the ship's deck. Okay, so we have got the sea. Okay, we've got a ship that dropped anchor. Let's say it dropped the anchor, so we've got the seabed. Let's say it dropped anchor down here somewhere, so it would have dropped anchor when it was here, except it's drifting. Okay, so now it's over here. So it's dropped anchor, and now the anchor is here. So it says find the maximum horizontal distance that the ship could drift. So we want to find the horizontal distance. Okay, that's what we're trying to find. From its original anchor point. If the anchor line is 200 metres long and it is 50 metres to the... Okay, so the anchor line is 200 metres. So I've just drawn that a bit far there. Okay, and it is 50 metres to the bottom of the sea from the anchor line, where the anchor line ends at the top of the ship's deck. So from here, the bottom of the sea is 50 metres. My diagram's not to scale, but that doesn't matter. If there isn't a diagram, drawing a diagram, identifying where the right-angled triangle is. it's going to be here. So we've got a right angle triangle. X is the horizontal distance, so not the hypotenuse. So in terms of setting up Pythagoras' theorem, x squared plus 50 squared equals 200 squared. Okay, so x squared equals 200 squared minus 50 squared. So 200 squared minus 50 squared is 37,500. And so x is the square root of 37,500, which is approximately, Control Enter, we want our answer correct to the, Control Enter, we want our answer correct to the nearest metre. So our units here are in metres, so to the nearest metre just means rounding to the nearest whole number, so that's approximately 194 metres. So the ship could drift up to 194 metres away from the point where it dropped the anchor and still be anchored. Part B, an extension ladder is used to paint windows on a multi-level house. The ladder extends fully to 6 metres, and to be safe, the base of the ladder is kept 1.5 metres from the house. At full extension, how far vertically can the ladder reach to paint the windows? Correct to one decimal place. Okay, so we've got our house and we've got the ground. We assume the house was well built and it's a vertical house. We've got a ladder. Okay. The ladder extends fully to 6 metres, so the length of the ladder is 6 metres. And to be safe, the base of the ladder is kept 1.5 metres from the house. So this base of this triangle is 1.5 metres. And we want to find how high can the ladder reach. So we're trying to find this height here. Okay, so again, h isn't the hypotenuse. H squared plus 1.5 squared is going to equal the hypotenuse, which is 6 squared. So h squared is 6 squared minus 1.5 squared. 6 squared minus 1.5 squared is 33.75. So h is the square root of 33.75, which is approximately, what are we doing? Correct to one decimal place, so 5.8 metres. So with our 6 metre ladder and making sure that we still have the ladder pulled out from the house at a safe enough distance, we can reach up to a height of 5.8 metres to paint the windows. Okay, the last thing I want to talk about in the Pythagoras video is this idea of a Pythagorean triad, or sometimes they are also called Pythagorean triples. Okay, so a Pythagorean triad or a Pythagorean triple is a set of 3 whole numbers that satisfy Pythagoras' theorem. So the most famous or most commonly known Pythagorean triple or triad is 3, 4, 5, and it's a Pythagorean triad because 3 squared plus 4 squared equals 5 squared. You can check that. 3 squared plus 4 squared is 9 plus 16, which is 25, and 5 squared is also 25, and so these are equal, and so therefore they make a Pythagorean triple, which means that we could, if we were to construct a triangle with side lengths of 3 and 4 and 5, we would know that this would have to be a right angle here because it fits Pythagoras' theorem and therefore it must be a right angled triangle. Okay. So once we know one triple, for example 3, 4, 5, we can generate other triples by scaling it up. Okay, so if we were to double all those numbers to get 6, 8, 10, that would also be a triple. 6 squared plus 8 squared will equal 10 squared. Okay, again we can check that. 6 squared plus 8 squared is 100, which is 10 squared. Okay. Similarly, if we were to multiply all the numbers by 3, so 9, 12, 15, that would also be a triple. Again, you should be able to check. 9 squared plus 12 squared is 225, 15 squared is also 225, so that's a triple. We could multiply all the numbers by 10, we could multiply all the numbers by 25. So we can create infinitely many more Pythagorean triples simply by scaling up the basic triple. Okay, a triangle has side lengths of 8 centimetres, 15 centimetres and 17 centimetres. Is this triangle a right-angled triangle? And if so, where is the right angle? Okay, so we need to check that when we square and add together the 2 shorter lengths, it's the same as the square of the longer length. So what I don't want you to do in this sort of thing is we shouldn't start by saying, well, 8 squared plus 15 squared equals 17 squared, because we're trying to show that we don't know if it's equal. Okay, that's what we're trying to test. So you work out the left-hand side and the right-hand side separately. So we'll work out what 8 squared plus 15 squared is. Okay, so 8 squared plus 15 squared, that's 289. And then we'll also work out what 17 squared is, and if it's also 289, which it is, then we know that 8 squared plus 15 squared equals 17 squared. So you don't start by making any assumption, you calculate the two things separately, and then now that they are equal to each other, now we can draw a conclusion from that. Okay. So therefore, since 8 squared plus 15 squared equals 17 squared, the triangle must be right-angled. That's because it fits Pythagoras' theorem. Okay, and we also know where the right angle will go, because the right angle is always opposite the hypotenuse. So the longest side, 17, has to be the hypotenuse. So the right angle will be over here, which will be between the two shorter sides, 8 and 15. Okay, so since 8 squared plus 15 squared equals 17 squared, the triangle must be right-angled. The right angle is between the 8 centimetre and 15 centimetre side lengths. Okay. So, you can have a diagram to help you illustrate that. So if you've got 8 and 15 and 17, there would be your right angle there. Okay, exercise 17D, you can do all those questions just practicing and reviewing Pythagoras' theorem.